Hello, this is David Braun, and we're going to run a practice problem in the TLeaves valuation processor. I'm going to have this sheet here a second, and you can take a look at what the valuator does and what the processor does, and you can read what I've written here about it. Now, the valuation processor is an attempt to meet the needs of appraisal modernization. We're actually trying to do that in the industry on all fronts, on the databasing, on the forms, even how the mortgage brokers and the mortgage companies handle their data, to how the AMCs work. And one of the main parts of the puzzle is the analysis that the appraiser does. It's generally considered that the appraisers don't do enough statistical analysis, and they take too long to do what analysis that they do, and they don't support their analysis well. So the processor is an attempt to improve on some of those issues. So let's just move through our problem. Normally, if you were doing a real assignment, you would start on this page. This grid is filled out with some old data, and it gives the user that's new to this an idea of what it should be. And basically, you've got your subject and 5 comps, and you have to use 5 comps exactly. You can't use more and you can't use less. And probably the hardest thing you'll have to learn right off is how to rate the property components. But that's in my user manual a little bit. We can talk more about that later. The processor is very unique. It doesn't really fit any mold that exists today. One of the unique features is what I call a training module. It's designed to help you learn to use the processor, but it also will help you improve your understanding of analysis in general. Now, the use of this will allow you to meet the USPAP's Advisory Opinion 37. And if you're going to use something like this, which is a valuation processor that does a lot of work for you, you should understand the Advisory Opinion 37. So what we have here is, since this is a practice, on this module, and by the way, there is, I think, a video just on how to use the training module, so we're not going to go into all of it. But basically, there's variables here for 5 sales, the property components. We're making some hypothetical comps up. And then we have some coefficients down here for like the garage. For each covered garage unit, it's 12,000. Each rating of the location from 1 to 5 is 10, so that's in here. Now, let's put a 15% market condition rate because rates have been very high. But let's get started. So once we have some information in here the way we want it, we hit transfer, and it's loaded now onto the sheet that we would start with, where we normally start with real data. And then we would send that into the processor, and we're going to ask the processor to help us extract the market condition rate. It's going to know that because we're going to put in some different rates. We think it's around 15%. So what we're going to do is we're going to put about, maybe we think it's more than 8, but it's less than 25. We're going to go to the high end because everybody's telling us that there are a whole lot of competitiveness on the contracts, and we don't want to be too low. But it's very unusual in my appraisal career of 40 years plus to have a market condition rate, over 12%. Now, what's happening, you can see down here at the bottom, some numbers are running, and these numbers are the Excel's solver running. We'll use the solver 3 or 4 times. Now, one of the unique things it's not new, but it's unique, is that the foundation that the processor works with is to convert the information into what's called composite utility scores. And that is a weighting. It weights each variable, and then it takes that weight times the rating that you used, and it kind of does an aggregate number for it. So each comparable and the subject have their own composite utility score. So that's somewhat unique. Also, everywhere that I've studied composite utility scores and I've seen the reports they do, it's always commercial. This is designed for residential properties, single family residential properties. Now, so right now, the solver is trying to weight, it's trying to find a weight for each variable so that when they match it with the rating, it has a high correlation to the sale prices. So the screen's, it's done with the weighting, and now it's trying to find the best interest rate. It's actually dividing up the range that we put and running several scenarios. Now it's made some charts for us, so we'll just take a look. This first chart came out at 11, then 8, 16, 16, 11, 19, 16. And, you know, as an appraiser, we know that we know it's over 10, so we're not interested in those, the 8%. And so then we've got, then there's 11, you know, so what we've got is actually 19 and 16 probably. And if we leave the 11 in, so we're from 11 to 16. And let's see what the processor thought we should use. The processor thought we should use 16.5. So why don't we just use 16? Now we know, since this is a practice problem, we know the real answer is 15. But this is leading us to about 16%. Now I'm clicking run again. Now the processor sees these two numbers are the same. So it says it knows that the evaluator wants it to apply 16% to the comps. So then it makes a kind of a new adjusted data set that's adjusted for the sales prices are adjusted for the dates of sale. And then it's going to try to find the value of the subject and the 5 properties. Now you can see the solver is working down here again. All right, now that took a little over a minute, about a minute and a half to run. And here's some outputs. Well, let me close this. A minute and a half, I'll close this. So here's some outputs that we had. How well did the processor do in weighting the variables? And it thought it did pretty well. About, you could think of a correlation rate between the composite utility scores and the sales prices, you know, over 90%. Now, actually, we don't just use one way. There's about 3 different ways that it calculates this. And I'm not going to go over each of these in this practice problem, but basically you can see here is a scale with green is good. Red can be a problem, so it's warning us that the subject's composite utility score is different. It's outside of the range of our comparables, and we'll see that in just a second in our chart. But look how well it predicted for the subject properties. It predicted very well for them. See, here's the actual prices, the predictions, here's the residuals, and here's what we call the MAPE, the mean absolute percentage error. I can see this line down here is actually supposed to be up that line, so I'll have to make a note to correct that for future versions. So the MAPE is 1.3%. Now, what we were talking about earlier, this is the subject. These are the five sales. You can see that the composite utility score is not within the others. And here we have a different situation that you can read about. We're not going to get into now, but where we've created some what we call mutant comparables. And you can see that the subject is over away from it. Now, here's some outputs that we got from 6 different methods. The first method I want to show you down here is the forecasting of the CUS, and it was 372,000. That's normally where a composite utility score would kind of stop. That would be the score, and you wouldn't have to make any adjustments. But one of the things we wanted to do was make this more traditional for appraisers. So what I did was I converted the composite utility scores and some of the other things into actual adjustment rates so we could do a traditional grid, and it came out 381, a little bit higher than this. And there's also, like say, there's 6 methods altogether. Now the ones that are blank, the significance level wasn't high enough for them, so we couldn't rely on them, so we just left them off. Now since this is a practice problem, this kind of said, well, about 376 is kind of in the middle of everything. Let's see how well it did. Okay. All right. So the TLeaves predicted 376, but the actual intrinsic value of our subject property is 370. So we're not too bad. We're less than 2% off. Now, what we would do next is we could go to a ranking, and the processor has ranked these in order. You see, they're not by comp 1, 2, 3, 4, 5. They're by the predicted prices. And it felt like the subject was going to be your highest predicted price. So what you would want to do is look at this, and there's quite a bit of difference that these fall off quite a bit. So what you would look for is that based on these ratings, you feel like it makes common sense that the subject is, a higher value maybe than these first two. So that way it lets you notice right away if there's something just crazy. Then we're going to go to the direct comparison approach, and we've got a grid here. Now this is not the basic UR/AR grid, but it is a functional grid, and certainly would be fine to use with a non-secondary market. Now, what we want to look at right now is how do we feel about our adjustment rates? Now, in the blue here, it actually tells our adjustment rate for a sales date or market condition. We know we use the 16%. The site, now the location, they're all the same, so there's no adjustment, so it's NA. The site is 5,000, and I feel really good about that. The condition, that may be a little bit high. Now, so you would just change it to what you think. So maybe I would put 22,000, just lower it a little bit. Let's say 22,000. Now, I don't like to touch the grid because it's linked. I mean, the gross living area rate until last, because it's linked and it changes, and as we change these others, it changes automatically. The bedrooms, I don't think that's bad. The baths, I normally don't use 10 in this market. I might put like maybe 4,000. And in this price home, I don't think in age, the garages add 21,000, so maybe I'll put 12,000. Okay, now I kind of got an idea, then I've run a quick run through. And like I say, this is a practice problem. So let's see how we're doing. This is 373 back to the value. So we're good, 373, and the actual intrinsic value is 370. So it's okay to look back and forth in these practice problems. The average deviation of the indicated values or the adjusted sales prices is low. It's like 1%. Now, those of you that are familiar with sensitivity analysis is based on the theory that as your adjustment rates become more and more correct, the indicated values will tend to converge on one number. And you can see that the adjusted rates here have an average deviation of just a little over 1%, which is really very good. And that's a lot determined by the random variance of sales prices in your market, which is another subject we won't really get into here. But that's what sensitivity is based on. So a lot of times, if you make a crazy adjustment, you can look down here and notice that these all got out of whack. Now, to help with this, I've created what's called a enhanced sensitivity analysis. Now, I'm going to turn it on. And what it does here, it gives a score for each of the adjustment rates. And these scores, 0 is the best. So 249 is not bad. Anything below 2000 is really very acceptable. And right now they're all about there except bathrooms is not. Bedrooms and bathrooms seem to be a little bit high. So what I like to do is you click on the adjustment rate for, and then you would click on the individual ESA button, and it would move it what it thinks is in the right direction. So it moved it down to 9 or almost 1,000, but I don't agree with that. And see, this is sensitivity analysis. This is no more accurate than any sensitivity analysis, and I'm going to overrule that. I'm just going to say no. I don't think that's right. And the bedrooms, I'll click on it and see what does it do. It raised it to 11. I wouldn't argue with that. This 158 I think is a little low. I'm going to put 165. I think this is probably a little high for a condition adjustment. You know, I might rather have 20,000. Okay, now I look at this and my adjustment rates now are 375, and like I said, I'm just going to cheat and look. So we really didn't change a lot. I just got my adjustment rates where I wanted them to be. I think they're more realistic. So this button is a snap to, and what you would do when you get, if you want to try it, when you get your adjustments to where as best you can get them, then you would click this and it will try to make these all as low as possible. The sum of these scores to be as close to 0 as possible, not low. Like say a minus 19 is not, 1900 is not better than 0. 0 is better, but it'll try to get them as close to 0. I'm not going to do that now, but you could and experiment with that. But what I want to do is I want to direct the processor. In other words, this is a 50-50 relationship, me and I help it. And I'm going to say, I think these adjustments are a little better than what you first gave me. So let's use these. And why don't you re-weight so that the other 5 analysis, remember there's 6 analysis, go with these weightings. So now it's done that. And I'll go back to the worksheet and I go to the bottom of the page. And then we would want to weight these, which I would, you know, you could weight these however you want. I'm just going to leave them where they are now. And we're coming out at 378. You know, you might say, I want to get this a little closer to 374, but you could be as high as 378. I might go 376. So I would change that until I got 376, and I would put 376 here, and then I could put my indicated value from my ranking and say we thought it was in line. We put 375. This gives a range plus or minus 5%. We might want to change that to 3, but now we would be done. And let's just see how we did then. If we did this, we were 376. We can go back. The answer was 370. This is still stuck on 378 because I didn't change it. So we would be within 2% of the intrinsic value. Now let's take a look at the report, because one of the big things that all the calculations that were done in this to get this, and there were a lot of statistical analysis performed in the background. Let's take a look at the report that we would get, and I'm just going to use the Excel print viewer here just to look at these. So there's page 1, and there's page 2, the second part, and it would, you know, I didn't really end up weighting these to the 376, but you would weight those. And then we go to the page that shows the actual data. It shows our subject and our comparables, and it shows their ratings that we used. Then the next page shows the charts for our market condition rate. And if you use more than 4 charts, you may have to put a line break in. I'll work on that to try to make that better in future versions. There's no reason that I shouldn't be able to do that. And I normally just use 4 charts. I would just leave that one off, but you could use all 7 if you wanted to. Then it also prints, let's go to the next page. Then it shows the ranking analysis. And on the next page, it shows the comparison grid, and it shows your adjustment rates. And normally, before I would turn this report in, I would turn the sensitivity analysis off so that these scores go away. They're more for the analyst to use. You don't want to try to explain that to a user of your report. And then on page 8, we explain the forecasting of the composite utility scores. If you look closely, you'll notice that the square feet are all the same. And that's because we base this on the price per square foot. So we had to adjust the sizes to be the same, and we would have used the same dollar amount that we used on the adjustment grid for the gross living area. So we adjusted those, and it shows the R squared and shows a chart. And then if there was, and there apparently wasn't, oh, there is, here we go, the regression analysis. Then here's the regression analysis that it made. So you can see that basically the processor works with you. There's really nothing in this that prevents you from doing anything you would have done before, or really helps you do things a lot. You know, it just adds the analysis part, but you have full control of it. It doesn't control you. Remember, you get to send input back to it. It sends input to you. We call that an if you see here, let me go back here. We talk about it, and we call it augmented intelligence. Here it is, where you get the strength of the machine and it gets the common sense and the supervisory skill of the appraiser. So now you've done all the analysis that's expected of you, but you don't do it by hand. You don't hand extract many adjustments. Now there are some adjustments you will have to extract when we get over to the worksheet. When you first start to run this, if you had a swimming pool, you would have to value it however you've done it in the past. Also, the finished and unfinished basements, you know, require you to figure that on your own. It's just not sophisticated enough with 5 sales to get this kind of accuracy on these types of adjustments. If there's something extra like an auxiliary house, you would have to do it separate yourself. Then you could just lump them in. Maybe one of your comps has a large detached garage plus their attached garage. Then you'd have to handle that. So there are adjustment rates. Probably the idea is you only would have to extract about half of the adjustment rate you normally would. That's the idea. Certainly you would have a report that would probably be somewhere like 10 times as much support for your analysis as other appraisers turn in. So basically that's an overview of the TLeaves valuation processor, and we'll call this practice problem 1. Thanks for watching.